In this video, I want to introduce the idea of swapping, which is something you guys have probably seen before. So the basic idea is this, right? A process can be in one or two places, right? And a process meaning both the code, right, and the data. It can either be, in main memory or in some sort of a backing store, right? So these are kind of our key terms. Now, for us right now, what we care about what we care about is main memory. Backing store is something we'll maybe talk about more in a minute. So the idea is this, right? Is I have this kind of secondary place that I can store data. And you can see my diagram, right? My diagram on the left, I have my, my main memory, and then on my right, I have my secondary store. On my secondary store, right, typically that's something like a hard drive, right? So I could either have a hard drive or an HDD or an SSD, right, a solid state drive. It's going to be somewhere else, right? It's going to be someplace that basically has more capacity than my main memory. Because typically, right, my main memory is limited. So I have here, maybe I have just 32 GB of memory. And over here for my backing store, right, maybe this is like 4 TB, right, 4 terabytes. These are kind of significantly different. And so the issue is, right, is that sometimes I'm loading stuff into my memory, loading stuff, well, all of a sudden I run out of space, right? And once I run out of space, and somebody wants to run a new process, what do? I need to basically kick something out. And so I need to take a process and swap it out, right? And so there's these little arrows here, right, basically to show, how things flow. So if I fill up my main memory, I take something out, right, I swap it out, and I move it to my backing store, right? And so all of a sudden it exists, over here. So here you can see, P1, P2, right? Those things have basically been swapped into the backing store. And so they live there, right? And eventually, right, maybe the user wants to use those programs again, so what does it do? It requests them, right? So it goes to the backing store and says, hey, can you bring those back? And so in that case, right, we swap in these processes. So it's like, all of a sudden, P2, gets moved back, and I have, P2 my main memory, and I can use it. And probably, I had to evict something when I did that, so maybe it was P1, right, that basically got, pulled out and thrown into the backing store. So overall, right, the problem somehow we're trying to solve is that my RAM, right, is going to be limited, right? Sometimes I fill it up. When I fill it up, how do I, run something new? That means I have to make space for it, right? Push it to somebody else. So jumping back here to the slides, there's some sort of questions here. One thing I mentioned is my backing store is really big, right? I want to have some sort of hard drive. In general, it's typical to use a hard drive or a hard disk drive to do it, right? Not a solid state drive. Think about it for a second. Why is that the case? Why do you use HDDs instead of SSDs? Why would that be? So one thing here, right, is basically the issue of limited number of writes and reads. So typically when we have an SSD, what we have to keep in mind is that hardware, right, one of the issues with it, right, I mean, it's very, very fast, it's nice, but it has a limited lifetime. So I can only write to it so many times before it basically freezes, right? I basically, have no ability to write anymore, right? It's just going to be stuck. And if I'm doing swapping is a very common thing, right? If I'm working on my computer, right, and I have, even, a lower amount of memory, right? So maybe I say I have only 4 GB. I'm going to have more swapping. Generally, it's like the more RAM you have, the less swapping you have, right? Versus the less RAM you have, the more swapping that happens. And so, right, some cases where I do a swapping, all the time, it's just kind of ongoing, right? It's something even called thrashing. Well, you're going to put a lot of wear and tear on your SSD. It's not going to last very long. A hard drive doesn't have that specific limitations, right? It has kind of a much, higher amount, or higher lifetime, I should say, right? And so it's a lot more suitable for a drive using to store your swap file on, right? Just to do swapping for, because it can stand up to that repeated reading and writing. So one overall thought here, right, is that this is going to be expensive. So whether I'm doing a swap out or swap in, it's going to cost me. I need to touch two parts of my systems, right? I need to change something in main memory, and I need to also change something in backing store. If I'm obligated, right, to use something like a hard drive, right, an HDD, my issue, right, is that maybe it's like my hard drive, I need to spin it up, right, I need to find the right platter, right, I need to, do all these things. That's going to be a lot of work. So sometimes what we want to do is actually try to minimize it. And so there are actually techniques, right, basically to cut down on the amount of traffic here, right? So if possible, we basically want to reduce how much time or how much data, right, we want to swap in or swap out. And maybe take just 1 second to think about that. Is there any way you could basically, or anything you could think of doing, right, that would enable us, right, to cut down the amount of data flow for either of those, in either direction? So here's a sample one. What I can do is that when I swap in a process, so I swap in, process 2, I don't need to delete it from the backing store, right? Because some systems, right, maybe will take the approach of, I need to get that space freed, so I'll delete that process. Don't do that. Instead, just leave P2 there. Then in the future, if somebody wants to basically swap out P2, well, P2 is already in the backing store. Maybe I only need to change, a little bit. I just need to maybe move a couple little pieces of memory, right, over the backing store, and then I'm done, right? So the idea, right, is that we don't want to, erase these things over here. We want to maintain them, because then it's like, well, if I need to swap that process back, well, it's already been stored there, so I'm good to go. So that'd be one way to do it. There's other ways as well. You can think about it more on your own.